Okay. Yeah. Hi, folks. So this is the first video in this series. I have been reading this book by Sam Newman called Building Microservices. And yeah, I'll be sharing all of the concepts that I read from that book. And yeah, let's get started. So in this video, we will mostly cover about what microservices are and what are the key differences between microservice and monolith. Uh, I'll come to the explanations and I'll also explain what these individual things are, along with their advantages and disadvantages, plus for whom microservices may work and for whom monolith might be a better choice, right? Because it's not a one-shot solution to all the problems that you're having. It works if done right. And yeah, let's get started. So this is, I'll start with the very first example. This is like a real world example in terms of like the things that you see in day-to-day life, right? So it is mostly to internalize why do we need to split some of the concerns sometimes, right? So, okay, let's get started. So let's say you are a owner of a giant restaurant, right? You are serving pizzas, tacos, drink, desserts, everything possible, right? So you have a kitchen as well, but if you have noticed that in like most of the restaurants, like you'll have one central kitchen where everything is cooked and prepared, right? So there will be like these counters and all of that. So what happens when like let's say on some day, right? Like something happened or like it's been building up for days and one day the counter became so messy that you cannot like it just needs deep cleaning, right? So what happens then? You can't really cook or prepare anything over there and the entire operation is halted for a day, right? So I'm trying to move towards tight coupled system. Like I'm trying to say that if the food counter is like if the entire food counter or like the that counter is not operational, the entire restaurant's business is not functional on that day. Okay. So I can say that everything is really tangled, right? Less room for new innovation and scaling is all or nothing, right? So let's say um, you someday you just wanted to like have a different setup or a new setup for wood-fired pizza, right? So you'll need to bring in like grills or something to install in the kitchen, right? But you cannot do it without like displacing some of the existing stuff, right? You will definitely need to make room for that or break something, build it over there, move some of the like some of the operations to a different location within the same kitchen, right? So you cannot basically experiment, right? If that thing is running, if that thing is working, even to experiment something or even to add something in the system, you need to think, right? It's not as easy. There will be some downtime, right? So this is a drawback of having everything in one place, right? It becomes very tangled and like you cannot really play around with it, right? So now we will come to a solution and see how we split that entire restaurant into a food court, right? Only, sorry, only if you have a little more place, right? You can split it into smaller stalls, like let's say pizza stall, taco stall, and drink and dessert stall, right? So now what happens is, let's say, if, taking the example that I gave earlier, you want to add a new type of pizza, like for like wood-fired pizza, and you have to add some news setup, right? So you can just isolate those changes over here, right? You don't have to touch this. Okay. So you don't have to touch this or this, right? You will only be making the changes over here. And yeah, you can leave taco stall and drink and dessert stall functional as it is, right? If anything goes wrong, or like you need to, let's say, maybe say, hey, I added that wood-fired pizza setup, but it's not working well. So I need to take the state of the pizza stall to a previous state. Like I need to revert, right? So you can also do that independent of how taco stall and drink and dessert stall is working. You can just do all of that. So the change is very isolated in pizza stall. So there comes the first point that it's independence. The changes are independent, right? Flexible scaling, fast innovation, and much more room for experiment. So what does this mean? Okay, flexible scaling means, let's say you have on one day, right? You have more, like you have a very huge demand for pizza stall, right? So you can just get more folks at, or like you can just maybe move um, folks from taco stall and drink and dessert all to the pizza stall, so that like you can really scale up the operations in that particular stall. And faster innovation. So faster innovation is very similar to what I was saying in the first part, that you wanted to try something, like you wanted to try a wooden, like wood-fired pizza stall, a setup inside the same pizza stall. It may or may not work. Even if it doesn't work, right, you can just scrape that out from the pizza stall, and you can get that stall back to the older shape, right? And it will just continue to work. So yeah, these are the advantages of this. Some of the things might not really fit, uh, like might not have a one-to-one mapping in between how I explained a restaurant versus how I am going to explain microservices, but it must have gave you like little bit of context on how, in some cases, separating separating the stalls, or like separating the concerns of pizza only being delivered, or like pizza only being processed in pizza stalls, taco in tacos, and drinks and desserts are being served in a separate stall, right? So every stall has their own concern, and they were all only responsible for doing their job in the best way that they can, right? So now we will move to a more formal definition of microservices. Cool. So like I'll just read it through, and then we can elaborate on what it is. So it's basically an independent reusable services that are modeled around a business domain. And it also there is also a note that a service here typically means completely separate OS process. Two microservices communicate via calls across a network rather than method calls within a process boundary. So what does this mean? Okay. The main microservice definition contains modeled business domain, like these terms. We will look in more in depth on these terms in the second video, that is like domain-driven design. I'll make a video on that. I'll make a video on that. But for now, we can think of microservices as it's a separate service that is responsible to do a job, right? And how do you decide that that service is going to do this particular job is by making, like deciding that, okay, this is a boundary, like it is by it is mostly using it is mostly decided by making a bounded context, like like taking the stuff from bounded context inside a service. And bounded context, you can think of right now, you can think of it as all the stuff which is closely related. Think of it in this way. that let's say, for example, will move to a different example as well. In a real world, like in case of softwares, we will go. Um, let's say you have in case of a social media platform, you have a single process running on a separate. So, what is a monolith? We'll come to this term as well. So, monolith is basically a single process running in an isolated environment. Like it's a, and it will have all the functionalities that your like your business or like your software is exposing, right? So imagine there is a social media platform, let's say X, right? So it has multiple functionalities. Few of them are auth, right? A user, only if they are authenticated, they can enter into the platform. It has posts functionality, right? A user can post some of the things. You can post, right, and it will be visible on your like timeline of the folks that follows you, right? It has user timeline feature, right? You can just go in your profile and see, like for a long time, what you have been posting, where you have replied, what are the things that you have liked, right? So these are some of the many things that X has. So and all of this is running in a monolith, right? So imagine the the resources that that single process, or like that the place where it's deployed might be taking, right? And it's very, very difficult to scale after a certain point. We will come to that. But now, let's say when you're trying to break it down, right? Because the scaling problem that comes up, you are going to take all of these individual responsibilities into separate chunks, which is called microservice. So this is, wait, okay. So this is auth is a separate microservice. This posts is a separate. We took all of the responsibilities of posts and post related things in a separate microservice, right? It becomes so posts will become a bounded context. Similarly, let's say if it was an e-commerce website, right? So all the things related to orders, think it in this way, like like order, receipt, invoice. So like basically things which are related to it, it will come under one. So it that entire thing becomes a bounded context, and the order becomes a microservice. So now that it might have become easy for you to think of microservices as it's and yeah, one more important point that I missed is it's very easily deployable and individually deployable. So if you see in the definition, microservices are independently releasable services that are modeled around a business domain. So we talked about modeling around business domain, right? Uh, for this, in the case of like X, we talked about auth as a separate concern, right? Posts is a different is like altogether a separate. Like it's a separate feature which has been moved to a microservice. Same goes with user timeline. Now, independently releasable is one of the key features that microservices offer, right? And yeah, let's go to advantages and disadvantages and key differences. There we can discuss more about what are the main differentiating factors. So if you see here, monolith, all the code is deployed as a single process, also known as like single process monolith. There are like monoliths are also of various kinds, but for the sake of simplicity, we will only talk about single process monolith, which is like the most common case of monolith. Like everything everything is a single process, and it has a single DB where like you are getting and storing and updating all the data from N2. Right. So what are the advantages? Let's come to advantages of monolith, right? So even before, as I talked, right, um, why do microservices even came into picture? What was the problem with monolith, right? So, like monolith in a way is always a go-to architecture, right? Let's say you are trying to build something from scratch. Y- Probably idea of splitting the things then and there won't come into your mind, right? Like you don't even understand the entire context of the problem that you're solving, right? So a lot of things becomes clear as as soon as you like keep moving, right? So let's say the very first point is it's a go-to architecture whenever you are starting out. It helps to focus more on deliverables and core logic, basically simple and straightforward development. So mostly you will see in startups that whenever people are starting out, they will try to get the most like MVP out ready as soon as possible, right? So and with that, like also the things that you set your mind that okay, you are going to build this, you might end up building a different thing altogether, right? You like people need to pivot from what they are building to what consumers actually want. So you have started in your mind, you have started building this thing and you wanted to reach to B, but you reached H, like a totally different product, totally different from what you have thought. So it takes time for even you to know that what your final product is going to be like, and then you will start thinking about modeling like microservice around like the domains, right? What are the domains that you are actually dealing with? Right. So this was the first advantage that you can always just start. And like most of the companies, I think no one starts with microservice, if I'm not wrong. Um, like it all starts with one single monolith being deployed, trying to vertically scale. Um, and once you start scaling it, you might start having problems. Then people usually move to microservices. Now, advantage of faster direct process communication as compared to inter-service and lower initial development cost and straightforward deployment and testing. So this is very true, right? So as soon as you are in a single process, like all the communication is happening within the same process, right? It will be fast, right? But as soon as you step into microservices realm, right, your request leaves that process boundary and move to a network, right? And as soon as your request is in a net is moved into networks, all of the network related issue, for example, latency, like it may also get dropped because of hardware failures in the way, right? So all of the things that a network communication, all of the drawbacks of a network communication which is there, you will also start seeing it in a microservices based architecture. So that's why you really need to be very, very clear around when you are trying to model a microservice, right? Ideally, you need to be like not really communicate with the other microservice at all. Like that's a very ideal case. You will definitely communicate, but as least as possible, right? And okay, so let's stick to advantages of monolith only for this moment. We'll come to other things later. Now, lower initial development cost and straightforward deployment and testing, right? You just lower initial development, as in you don't really have to think a lot around and a lot of and not a lot of niche expertise. Niche expertise is needed uh, when you are starting with microservice. Like as I said earlier, uh, it takes little bit of experience and like little bit of understanding of the domain that you are working in. So if you're working with monoliths, you can just start developing, start prototyping, and make that code mature enough to start serving first good set of your customers. So that is advantages. Challenges in a monolith. Scaling once again is a challenge, right? You either scale everything. Okay, so let me give an example. Let's say a very hypothetical example. Someone like, let's say on X only, a lot of folks started tweeting or like posting tweets all of a sudden. This may not happen in real case, but let's say, right? So posts functionality will, so if you think in terms of monolith, right? The entire monolith, that process is going to get a lot of post requests, right? You will start seeing like Surge or like the posts table, which is there, right? It will like immediately have a lot of new entries with other tables being unaffected if it doesn't really touches post functionality. But think about this, right? To basically, and since every table is inside the same database, you will need to scale up the database, the entire database, right? You will also have to you will also have to scale the server, like the application part, um, basically the backend, uh, vertically, right? You will have to increase CPU, you will have to increase like the RAM and all of this stuff, right? So basically, in case of microservice, vertical scaling is mostly a way to go. You don't really want horizontal scaling in, sorry, if I said microservices earlier, I'm talking about challenges in a monolith. So what I'm saying is, in case of a monolith, vertical scaling is always mostly the way to go, right? You don't really want distributed monolith. It has its own problems. We'll come to that also. So yeah, I think that is one challenge in monolith. Then as you add more people in the team, they will start stepping on each other's toe. It's very common problem in a lot of organizations, and that's why, once again, going back to the same point, separation of concern is really needed when you are dealing with a lot of people. As team grows in size, development efforts become slower to the point even adding a column in a table will become a cross-team project. So this actually happened with Netflix, right? When they were pivoting from monolith to microservice architecture, I was reading some blog, or I think it was in one of their conference videos, that the developer, they said that only to add a column in a table, right? It was a cross-functional team project where they just collaborated for a good chunk of time to get that added, right? So, yeah, it also depends on scale as well, but just think about the impact that monolith, like the challenges that monolith can have if you're on that kind of scale, right? Cool. So now we will discuss about microservices advantages and challenges. Cool. So advantages are independent deployability, right, and separation of concern. Then faster development from a point of view of microservice, and distributed nature of microservice improve the overall resilience of an application. This helps in fault tolerance as well. Okay, so we will start with uh, like expanding on some of the points. So, as we already talked, that independent deployability and separation of concern is a good thing in long run. Then faster development and distributed nature. So imagine you are working and there is no, and in case of clear boundaries, I'll also like to give an example in terms of organization context, right? Uh, there are a lot of people working on monolith, right? And some issue starts to happen in some place, right? Now, since that particular monolith or like that entire code base is owned by all the engineering team, it becomes really hard to actually point out whom, like, who should be responsible to fix that, right? It always gets into, so sorry. So yeah, this is one of the most like pressing issues whenever like team size grow. Like it's very easy to manage when you are a very small team, right? Like there are only few folks and they will all take a look, right? But and when I'm talking about scale, I'm talking about like 1,000 plus people, like even like 200 or 300 folks. If there is an engineering team which contains 200, 300 engineers, I really think that separation of concern, like the like which team is responsible for what part of overall functionality, it should be very well like laid out. Now, in case of let's say, now we'll talk about challenges with a microservice, right? Since it's mostly based on inter-service communication, network latency will come into picture. We already talked about this. Data consistency is a challenge. Scope of testing and debugging spans across different services now. Cool. So we will discuss a little bit about data consistency, right? Now, let's say you were dealing in a monolith kind of an architecture where, as I talked about X, right? A lot of people, when they started posting tweets on their on their home feed, the entire load came onto that one particular DB, right? And if it was, and it must have been manageable till a certain point, right? So you can almost always say that the data will be written or not written in the same DB because it just literally on the same node. It's not that you have to write on one table over here and the other table is hosted in some other region and you also have to write it there and then only the transaction is complete. So most of the things are like whenever on production databases, right? If something is really critical, it is mostly wrapped around transaction, right? It should be atomic. If either all the entire process, either the entire commit happens or it is rolled back. So let's say data consistency, why it becomes a challenge is uh, you have, let's say, a transaction that spans different databases or like different tables in different microservices, right? So how will like, and it may happen that it either fails, like distributed transaction is a problem in itself. We will explore this in a later point of time. But what I'm trying to say is it is easy for data to become consistent or like in a proper shape whenever you are dealing in a monolith service, monolith kind of architecture versus when you are in a distributed microservices architecture. Right. Now, scope of testing and debugging spans across different services now. Okay, so it's very easy to test out a monolith. Reason being, you can have an entire end-to-end integration test on that particular monolith itself, right? The functionality is all there in running in the same process. Database is in the same data, like all the table, everything is stored in the same database. You can get anything that you want and stuff like that, right? So you don't have to make inter-process communication, like inter-service communication to test the functionality end to end. So, for example, let's say if I try to come up with an example for this, it will be like, let's say you want to test out if a person is able to log in and post a tweet. So, in case of a monolith, the login feature and the posting of the tweet feature, all of it resides in the same monolith itself, right? So it's you can just call like hit an API for posting, and in the same flow, you can also just use the same data and try to post try to um, hit another API to post, right? But it will be like what I'm trying to say is the request scope will be limited to the same monolith, right? It did not go over network. The request did not go over the network. It was it was making rounds inside the same process. Now, in case of a microservices architecture, auth is a separate service. User login is a separate service, right? So let's say you have to test out a scenario where user is able to authenticate itself and user is then able to post a tweet as well. So in this case, what you'll have to do is you'll have to first log in, get that token or auth token, whatever, and then you'll have to also call a different service, which is totally relying in a different region. It might be in a different region altogether, right? It's a separate process. To reach to that process, you have to go via network. So you will have to then hit user's endpoint, try to log in, and like test that functionality, right? So yeah, that becomes a challenge in case of, so basically end-to-end integration testing is hard in microservice. Now let's discuss upon should, like, this is a very important concept, or like this is a very most, like, one of the most discussed question in microservices realm, that should it have its own DB, right? So like, from the very beginning of this video, I have been mostly focusing on this term about separation of concern. If you are sharing database, right, it's not really like your just application layer, like your backend layer, are not different, like deployed in different regions, but in the end, you are going to the same database. So it's not really ideal. Different workflows, or like different requests, or like different kind of flows should not really be interfering in database operations, only because, so that's what, if needed only and only, then you need to share the database, or else you should generally, it's a very general pattern that each microservice should own like, or should have their own database. So like, yeah, joins joins are in general very fast if you compare it with, like, in this case, however, like, only what I would say is only share the database in case it's a very anti-pattern thing, but in case your joins is giving you a better result, or like a significantly better result, that as compared to when you have to hop onto network and then reach to a different microservice, get that data, and then join it, right? So in that case, so in case of sharing the database, right, by two different services, join is going to happen on a database layer. But in case of microservices, when two different microservices are having their two different databases, join is going to happen in application layer. Like, the main data refinement, that you what you wanted to be propagated in the upstream, that particular logic will happen in application part, right? So let's say A will first get data from A. Okay, then it realized that, okay, it also needs data from B. So with certain parameters, it is going to call microservice B, which in turn will call B's database, g- return response to a microservice A, and then A will perform some like merging based on any logic, and it will then return the response back, right? So yeah, we can think of microservice, like, in ideal case, microservice should have their own DB. Now, let's, as we were discussing, for whom it works and for whom it doesn't, I think we already touched base upon this, that if you are really starting out, uh, and you are in that even far from MVP phase, when you are stable and when you really start to see issues in your devs team, or like um, right, that okay, things are not moving at a faster pace, maybe try to split one by one into microservices. Like, microservices doesn't really guarantee velocity from day one. It's a very long term effort, and it should always be done in chunks. If you try to break the system like your monolithic system into microservices all at once, you are only going to halt the entire business operation, and like you're only going to slow down your speed even further, right? So yeah, that's what. And I think I have covered most of the stuff that I wanted to discuss, right? Cool. So yeah, we will meet in the second video where I talk more about how microservices is more of a like organization. Like whenever you are splitting a monolith into microservices, it also causes change in how organization is structured, right? So there is a very famous law called as Conway's law, which kind of tries to establish a relationship between how your organization is structured and how your entire code is structured. Like how does your software architecture looks like is very, very related to how your organization is structured like. So yeah, we will touch more on that in the next video. Till then, thanks for your time. Please leave a feedback if you guys like this video, and yeah, it will give me a direction on how I can improve further, what all things I can add or maybe remove. Cool. So thanks a lot for your time. Thank you.